Cathy O'Neil, who will speak about how is math used outside academia.
My job.
Thanks so much, guys.
You can do it now.
I appreciate everybody being here, considering that there's a competing talk next door. I'm especially honored that you chose to come here.
Oh, what's the other talk?
I don't know, but feel free. So, just a little bit of background about myself. I was a number theorist. I got my PhD in 1999 at Harvard with Barry Mazur. And then I went to MIT as a Moore instructor and another kind of smallish postdoc, like short postdoc. And then I got a job at Barnard College, Columbia, assistant professor. And in 2006, I decided I wanted to be part of the real world. The energy of New York City was exciting to me. I didn't know what to do, so I called up my old friend Eric Wapsick, who was working at D.E. Shaw, and I said, hey, what's it like to work at
What's D.E. Shaw?
D.E. Shaw?
D.E. Shaw.
It's a hedge fund. And applied there, got a job. I started working there in May 2007, just when the credit crisis was starting. And it was really interesting. I got like a front row seat on the whole thing. I worked with Larry Summers. For 2 years I was there. And in 2009, I decided I'd had enough. And I quit, and I decided to try to fix the system. So I decided to try to get a job with a regulator, but it turns out no regulators wanted me because I'm not sure why.
Something was wrong with before?
Yeah, the credit crisis kind of exposed problems with the financial system. And I'm kind of like a let's fix this kind of person. So I was like, I'm going to go fix this problem rather than just taking advantage of these problems. And I tried to get a job at a regulator, the CFTC. I worked in futures, so you might think the futures regulator would want me, but they didn't. Anyway, the point is I ended up at a risk firm called Risk Metrics. And I thought to myself, if you can fix the risk models that people use, then maybe you can improve the system indirectly. And I was thinking, on the other hand, if you make a crappy risk model, then you're actually not improving. You're making the system worse. Because people will assume that it's a good model. But if it's actually crappy, then that's only adding to the lies. So I worked there for 2 years, at the end of which I realized there's yet another issue, namely, even if you work really hard to make a good risk model, which I did, I worked specifically on credit default swaps. Even if you work really hard, it's a question of, are they going to be used? Are these models actually going to be used? And I came to the conclusion that they were not. But that's a sort of a political issue. But it's not irrelevant to the talk, so maybe I'll go back to that at the end. So I want to talk today about how math is used outside of academia. And by the way, I hope I'm not talking down to anybody in this lecture, if you might know a lot about this stuff. I'm talking about, essentially I'm assuming I'm speaking to myself before I started working outside of academia. Okay, so I did not know anything except mathematics. That's what I trained in, and a little bit about African drumming and Hungarian. That's about it. So I have a blog, and I write every day on my blog, mathbabe.org, and I asked my readers to tell me how math is used outside of academia, and they gave me a lot of answers. And some of the answers are listed here: climate modeling, financial modeling, medical research, biology modeling, sports modeling, healthcare, cryptography, advertising. I actually should say that after leaving finance, I worked in internet advertising using very similar techniques that I'd learned at D.E. Shaw to predict people's actions on a website. So it's rebranded as called data science instead of quant, but that's what I do in advertising. I quit that job recently. Recommendation engines, fraud detection, geophysics, defense. So there's lots of different teacher evaluation, language recognition, H-score for published researchers. Do you guys know what that is?
No.
Okay, I'm going to go into that. That's going to come, but that's I threw that in for the mathematicians in the room.
Citation.
It's kind of a citation. It's like how many papers do you have with this many citations? Yes. It's one of the worst models ever. Just throw that in. We're going to get to that. But I'm not going to talk about all of that. Obviously, that's more than one talk. I'm going to focus instead on predictive models. Good question. Is this actually math? Like if I'm talking about predictive models like linear regression, logistic regression, decision trees. There's like a list of techniques. You might say, hey, I work on algebraic geometry. I don't think that stuff is math. Good point. It's certainly not as broad as math, right? On the other hand, it is what mathematicians get paid to do if they leave academics, essentially. I'm not saying that's the only thing they get paid to do, but most mathematicians, when they say, I'm out of here, I'm going to go work in the real world, they end up getting paid to do predictive modeling. Partly that's because it's hard and mathematicians can do it, so they get paid well to do it, so they gravitate towards it.
Well, there's another way in which it could be math, not just that mathematicians do it, if it had some mathematical structure.
Certainly does.
If it did, to the extent in which it does.
Yeah. It is math, but it's not as broad as sort of math with a capital M. That's my point.
Well, it's not equal to math.
No.
It doesn't contain that.
But the title of my talk is How Math is Used Outside of Academia. That's why I'm just pointing out that it's just a little piece of math, but at the same time, it's not just a little piece of math outside of academia. It's a very large part of math outside of academia.
When you say what mathematicians in the industry do, you mean as trained mathematician or as active mathematician?
Let's not get into semantics too much. Like I don't really. When I left academics math, I'm still a mathematician.
No, I'll answer. He meant what you said.
Yeah.
He's asking what you said.
Yeah.
What you said is as trained mathematicians.
Yes.
They're not still doing math.
I know. I disagree.
I think that's
let's not be too philosophical, but I still consider myself a mathematician. I'm just not an academic researcher mathematician.
You're both there?
No. But that's a philosophical discussion. The other thing I want to say is that although it's not necessarily all of math, this is the public face of math. And that's a very important point that is really kind of the point of my talk. I want to talk to you guys about how people think math, what people think math is, and how they are confronted with math on an everyday basis. It's something, I said beside calculus, but really I want calculus to be an example of this. If you think about the undergraduates in a university, it's about, statistics at NYU anyways, I think about 85% of undergraduates who take a math class in the math department take only calculus. So in some sense you could think of the undergraduate's perspective of math in a university is calculus. That's what math is to them. And that's a similar way, here. For the public, this is math.
Boy, what about statistics? A lot of them take statistics.
I'm talking about only math.
That's math.
Yes. No, but I don't know that statistic. Because I was talking to a math person when I talked to them, when I heard that statistic. Okay, so now I've kind of hopefully given you a reason why I'm focusing on predictive modeling. I want to just define my terms. What is a model? It's something that takes data in. There's a toy universe inside there explaining how things interact with each other. It sends out, the output is a prediction of something that's going to happen in the future. Any self-respecting model should have an evaluation method. I just want everyone to nod, because later on we're going to come to examples where that doesn't happen, and that's a problem. I'm going to say that now, so you'll be prepared. One of the major things that everybody knows is that it's statistics as well as math, and statistics can be manipulated. In fact, it is manipulated. So why should you guys care? Models are powerful on the one hand. They do lots of really useful things. They're not oracles. They're not foolproof. And you guys know that, but not everyone knows that. In fact, models often rely on the trust people have in mathematics. People trust mathematicians. They trust mathematics. They think of mathematicians as having a purity. Like, they trust us. Mathematics, of course, does have purity. And actually, one of the reasons I'm here is because I believe that to be true. The problem is that it's not exactly the way it's not. Let me just stay on this. The problem is that it's being used by other people who aren't trustworthy. This sort of badge of trustworthiness is being used by other people that aren't mathematicians, but it's being leveraged. So I want to talk about the authority of the inscrutable. This is my definition. Actually, I just reread John Ewing's article. I don't know if you guys have looked at it. In John Ewing is like the president of Math for America. He wrote a really good article in Notices of the AMS a couple of years ago about mathematics by intimidation. That's another way of saying this, but the idea is when we tell them, look, you did really badly on this, whatever this is, it's a model. Your score sucks. And they say, well, can you explain what I did wrong? You're like, no, you wouldn't understand it, it's math. That's the authority of the inscrutable. They're saying, you wouldn't get this. It's too hard for you. I'm not going to explain it because I don't understand it either. But nobody understands this. But mathematicians understand this, and it's magic, and it's true. And it sets people up as superhumans if they're mathematicians. Sometimes we don't care as a culture. Mathematicians have this tendency to be like only fixated on the next theorem they want to prove, and they don't really care how mathematics is being represented or manipulated. Sometimes that's because they're just not interested, and sometimes it's because there's a conflict of interest. It's not so bad to be thought of as a magical being. I remember when I was at MIT, on, I think, Arthur Maddox's door, he had like a little list of the most respected professions, like it was a poll, the most respected professions in the country. And mathematician was like number 2, and after that was mayor. Like we got respect, That's kind of cool. Who wants to lose that? So I'm just pointing out that mathematics is used, these models are used to manipulate politics. I'm going to give examples of that. On the other hand, I think mathematicians are moral, and we shouldn't let this happen. So that's sort of like I'm giving you the bottom line of the talk. Now I'm going to try to give you some evidence of what I'm saying. So here are the salient properties of a model. I want there to be some kind of formal definition of a model. I'm not going to have everything here, but it's going to be enough for you guys to get the idea of what I mean by a model. So there should be a name. I know that sounds almost idiotic, but names are actually by themselves political tools. There's an underlying actual mathematical thing going on, which is almost never explained. There's some underlying assumptions, there's some input, and there's some output. There's a purported goal, and there's a political goal to every model. There's an evaluation method, at least we hope there's an evaluation method. There's gaming potential for the model. So what is it gaming? What does it mean for me to game a model? It means I know how that model models the world. Let's say it's evaluating me. Yes. But specifically in the world of models, I know it's using this as a proxy for something, and I'm going to make this something look good by making that specific thing look good, but it's not actually good. Whatever that means, that's gaming. And then there's the reach. How important is this model? How many people, and this is what I care about, how many people does this model affect? Does it affect every single citizen of this country, or just the 4 people in this room? Like, that matters. So the first example I have, which I'm going to go through pretty quickly, because I could spend the whole talk on it, is called value at risk. It's the way banks and other financial institutions decide on how risky their portfolios are. And the idea of it is that you look at, it tells you how much value you have at risk in your portfolio. How much money could you lose? The underlying model is a Monte Carlo engine, and you rank things by how much you could lose in different scenarios, and you take a percentile. So you might say, my 95th percentile of R is I lose 5% of my portfolio. That means 95% of the time, I'm not going to lose more than 5% of my overall value. My 99% VAR to 99th percentile, I will lose 25% of my portfolio. 1 out of 100 days, I can expect to lose 25% of my portfolio. That's the idea. To calculate your VAR, you actually build a covariance of your returns of all the instruments in your portfolio, and you have some kind of decay, so you forget old information at a certain rate. I actually have the equation for this as an example when you're taking the variance, but really all it says is a weighted sum of new information and old information. It depends on a parameter called S. So if S is, so this is your weight on the old information, and this is your weight on the new information, 1 minus S. So if S is 0.999, you're forgetting things very, very slowly. If S is 0.9, you're forgetting things quickly. And you should think about it as like a half-life of your information. How quickly do you want to forget something? How quickly do you want to learn something? So you want S to be high because you don't want to lose stuff from the past, but you want S to be slow because you want it to be very reactive to new information. So it's a balancing act. Then what you actually do to calculate VAR is if you have n instruments, you take independent normal draws. So you just take random numbers from a normal distribution, you force them to be correlated via a little trick because you have a covariance matrix. So instead of having literally n random things, you now have n things that are as related as your actual instruments seem to be in your portfolio, depending on this decay measurement of your interactions. And you calculate the P&L. You take those n returns, those correlated returns, you say, what if a market day happened that had exactly these returns? How much would I lose or win? And you do that 1,000 times. And about half the time you'll see that you've made money with those random things, and about half the time you'll lose money, and then you take the 99th percentile to see what the worst case scenarios are. Question?
Is this how hedge funds work?
This is a very standard technique. Everyone does this. Most people do more than this. And the question of how much more than this, it depends on how much they care about risk. No hedge fund, which cares about its own money at risk, would just stop there.
Banks have to do that also.
Banks have to do that, but they don't care. In fact, they're going to choose, depending on which bank it is, if it's a too big to fail bank, they really don't care. So they'll choose whatever makes it look the best. And there's lots of choices here. So the underlying assumption is that you have normal distribution. That's a normal distribution. I did that with Python. This is actually a distribution I got looking at credit default swap returns on a one-day horizon. So this is what it actually looks like in the credit default swap model. So you can see it's not normal. Why does it look like that? Well, it's a credit market, so people change the price depending on whether they are worried that a company is going to go out of business. And it turns out that people mostly don't change their opinion that often, but when they do change their opinion, it changes a lot. So it's not normal. Okay, so one thing that means is that your estimate of your variance, depending on how quickly you learn new information, how slowly you've forgotten information, is almost always going to be an underestimate of your actual variance. That will underestimate the value at risk as well. If you care about risk, you make up for this kind of thing. But if you're trying to hide risk, you don't. So the input is daily market data. There's problems with that input already. There's misaligned time zones. Japan markets close much earlier than New York markets. Do people fix that? It depends on whether it helps them or not. Most people don't fix that because it tends to underestimate correlations. Markets are a lot more correlated than they look if there's a misalignment. But that benefits people who are trying to hide risk. In the end, you get a single number out. That's the output, a single number. That's, in fact, why VAR is so widely used, because it's something that people can say, look, it's so precise that it must be accurate. It's a very nice feeling to say, this is how much is at stake of my portfolio, even though it's almost meaningless depending on how much you gained in.
But do anybody in the industry trust that?
Nobody trusts that.
Who agree?
The purported goal is risk measurement. The political goal is, first of all, making a CEO feel like they have control over their portfolio, or whoever owns the portfolio, and for regulators to say they did their job when they force you to give the number. The evaluation method is actually not that hard. You can see if it's a very simple model, right? You're saying 95% VAR is saying 19 days out of 20 you won't lose more than this. But you could just see whether that was true in the past. There was a spectacular failure in 2008, but it's never been very good. The gaming potential is like widespread. And that's what we see. For the most part, when we see people getting away with stuff in finance, they are gaming the VAR. They're doing probably other things, maybe just outright fraudulent things, but they're also gaming VAR.
What is whale London?
Oh, there's something called the London Whale, where JP Morgan Chase lost $8 billion and counting. based on a trade they made. They was calling it a hedge. In an office that was supposed to be hedging, but it was actually a bet. But they called it a hedge because they managed to game their VAR model to make it look like a hedge temporarily until it failed. Sometimes you're gaming the VAR to make it look like things are less risky than they are, but they really aren't as risky, and as safe as you think. So when they actually fail, then you're screwed, and you have to be like, oh, whoops, the models must have been wrong, which is what happens.
Well, I was going to ask, why would people want to game this? And you just gave an example.
Right, in that case,
make the bet. Allow them to make the bet.
Allow them to make the bet. Because in London, they were worried about regulations like the Dodd-Frank stuff coming in, where they wouldn't be allowed to make proprietary bets. So they had to hide them in this CIO office, which is supposed to be like the office that makes sure that the whole bank as a whole is hedged. So their job is to literally make things safe.
What did they do to those guys?
They fired some of them. Nobody went to jail.
They got very rich.
Let's just be clear, nobody went to jail. The woman who was in charge of it retired with something like, $200 million. This is a very large problem. This is a great example of us thinking that those guys have it under control because they have risk models.
So our math is doing more harm than good, is what you're saying.
I think in some sense, I think the cat's out of the bag with VAR, but people don't have a replacement for it. And in the meantime, because people did trust it for so long, the system has gotten so complicated and complex that regulators have no hope to actually fix it or regulate it.
It's not everything is like this black shoulder, the same problem. These
Yes.
are all completely false models based on completely false assumptions that everybody use more or less, and that's it. I mean, what's rotten is the people, it's not the math or the technology.
I agree. At the same time, I think as mathematicians, we do have something to say about it. I think as mathematicians, we still can say something about that. I agree with you that it's not enough to fix these models. People will figure out a way to manipulate the models if they are corrupt people. Agreed.
So, way back at the beginning, I had a deep question. Is you sort of pretending that we should improve the models. You're pretending that there's some arbitrary reason why there should be a good model. See, these are complicated systems. We don't understand their structure, so why should there be good models?
Very good question.
According to Mandelbrot, I mean, there is no good way to do it, except that he spends half of his life trying to find some. But those are half of his life trying to say that there are none.
If you're asking for a proof, there is none.
Or even a strong belief.
I think actually you've come to one of the reasons I want mathematicians as part of this conversation, because mathematicians, in my experience working outside of mathematics in the real world, are one of the few groups of people who can admit that they don't understand something. That is a rare aspect.
But on the other hand, you have a building next door, which seems to indicate that, at least sometime, and on long periods of time, you can have things which work. Otherwise, the building next door will not be there.
I never said things don't work. In fact, I said that if you're wanting to game something and make it look like your risk is not large, you can do it with these models. And these are the models that are used. I worked in a hedge fund which made money.
So they work. So something works there.
Absolutely, there are things that work. Yeah.
That's work well.
I mean, you're just saying the transparency of the risk that's going on is not
Right.
It's not there.
By the way, I actually think, in moral terms, like people making money and putting their own money at risk, okay, that's one thing. The reason this really aggravates me is because it's people putting our money at risk. We are the ones bailing out the banks when they fail. That bothers me.
All the pension funds, which are big players.
Yeah. Okay. Let's not go. Let's finish my talk and then we'll talk later. Hope you guys come to dinner. Okay. So the second thing, which I think is, so that people kind of understand what I just said. They're like, yeah, finance. Those people are corrupt. This is a different example. Okay. This is an example about a model which is used in public school systems right now to help decide whether teachers get tenure in public schools. Let's set aside the question of whether tenure is a good idea in high schools or in universities. This is an important model, okay, that's being used right now in New York City, Chicago, and Los Angeles. It's called the value-added teacher model. Let's look at that name for a second. It's supposed to indicate that it's wondering how much better a teacher is than average. How much value does a teacher add? The underlying model purports to explain, to sort of estimate for a given student with a given teacher, knowing the characteristics of the teacher and the student, what's the score of next year's exam, considering the score of last year's exam? Sorry. Knowing the scores of your exam last year, what should the score be this year? Okay, it's supposed to estimate that. So that's part of it. And then figure out see what it really is, and then sort of attribute that difference to the teachers. Does that make sense? Of course, this is a counterfactual. It's really hard to know what would have happened without that teacher being there, right? So you're talking about what would this student have scored if they had been in a random class rather than this class with this teacher. It takes into account attributes at the student level, the classroom level, and the teacher level. But of course, because it's a counterfactual, it's hard to know. You can't actually measure its accuracy. On the other hand, I would love to see the purported scores. I'd love to see just the distribution of them, because I expect that they would be insane. This model is so bad, it's so inaccurate that I'm guessing that if you looked at the projected scores, you'd have things that are negative, things that are higher than possible. This is not a good model. So the underlying assumptions, which are big, are that you can account for externalities and that you can have error bars that are small enough so that in the end number is meaningful.
What's externalities?
So I'm going to talk about that. Let's talk about errors, sources of errors. You have to score the test, you can make mistakes. Some problems are harder than others. They model that sometimes. Some years of classes, students sometimes are smarter than others. How do you model that? They have a model there. Some tests are harder. That's a big one. My friend who's a principal in New York City public schools noticed that test scores went way up when Bloomberg was up for re-election. That happens a lot. Okay, tests themselves are manipulated. How do you account for that? It's totally ignored. You normalize differently for different years.
Tests from one year to the next are harder than the other. So you can, okay.
Yes.
What are you telling us here? About what is being the practice, or about what is a necessity, or because some of these things, even if they are bad, could be corrected by doing it well?
I'm just saying that there are various sources for error when it's actually done. When it's the way it's actually done, yes. And I'm not saying, I don't have right now a position on whether you could do this well. I think it's something like the VAR. So far, doesn't look good for doing this well. There's, because it's very ambitious to try to take away all the externalities and keep the errors small and actually have a meaningful number at the end. Can you do that? I don't think so. My guess is no. There's various errors inside the model that are correlated. They correct for those. There's model error, like the actual model might be wrong. You might just not know how learning happens. They also have this weird Bayesian shrinkage term. I looked into a technical paper. I read it, and I'm like, this doesn't explain it on the one hand. Frustrating. On the other hand, every single step of this has a mini model inside the model, which could have errors. What are externalities? You're supposed to account for what's under control by the teacher. So they make choices about that all the time. Things like how poor the kids are. Is that under control or not? I don't think so. But they're like, well, we don't want to lower expectations of poor kids. So let's decide that that's under control. It's a political decision, is my point. So what does that mean? The consequences are that this punishes teachers at tough schools. There's all sorts of ways you could see that the way they make these decisions about what's under the control, what should we account for, essentially punishes the teachers. On the other hand, it also punishes teachers that deal with very, very good students. Like if you have students that get 98% one year, what can you really do with those students? You can't, if they get 97% the next year, are you a bad teacher? That's a major problem actually for teachers of very, very good students. So the input are the standardized test scores and all these attributes. The output is a single number a teacher gets for a given grade for a given subject per year. It's actually just a linear regression with lots of sublinear regressions and also lots of correction terms, those which are opaque. The samples are relatively small. Even though New York City is big, you're talking about a single subject, a single year. So that's kind of another source of error as well. There's lots of missing data, and this is actually looking ahead into how people game this. The easiest way to game this is to give detentions to kids who are going to perform badly on tests. That happens all the time.
What, you mean so they don't take the test?
Yeah. As soon as there's a student that doesn't have a test score, they're thrown out.
The big cities do not consolidate their data.
They do like talk about how many absences there are in the year for that student. That's one of the attributes.
No. Consolidate the data between, say, New York, Chicago, I mean, all the big
Combines
cities.
New York,
You have a larger
put all of their data
sample.
together.
No way. They do not do that. And one of the reasons they don't do that is because they're competing standardized testing, scoring,
So it's the same
consultancies. That it's really a money laundering
as
scheme.
for operational risk in banks. I mean, people want.
They're not going for accuracy here. Like that's really my point. If they're going for accuracy, they would be doing things very differently. I just want to say that it's very different.
Oh, you are sure it's not by ignorance?
Let me give you an example. Okay, this is my example. So they did this weird thing where they decided not only to use this for tenure decisions, stuff like that, but to publish all the teachers and all their scores in New York City, in New York Post. Basically a shaming mechanism for these teachers, and not knowing that it was almost a random number generator between 1 and 100.
It was all what?
It was almost a random number generator. This model, which is supposed to tell you how much value you've added, is so inaccurate. And here's how I know it's inaccurate. Just one second. Somebody looked into that data set and produced this graph. This is for teachers who taught math the same year. They taught math 7th grade and 6th grade. So they got 2 different numbers. Same subject, same teacher, different years. This is the XY plot of that. Okay, so you have...
What is abscissa and what is alternative?
Who's the ergodic theorem?
So
it's 2 different ranks for the same teacher.
So I'm a teacher, I got a 0, so this point right here. I was told I have a 0 value added, worst possible type of teacher in 6th grade math, but I have I'm a wonderful teacher when I teach 7th grade math. It makes Now, keeping in mind that these models are supposed to extract all the particularities of the actual year and actual subject you're doing. That's the job of this model. It's supposed to give you your value added score as a teacher. These are actual numbers. It's 14% correlated.
Which one did you teach first?
Same here. Yeah, like which before lunch or after.
Yeah, I've done it. Sure, that counts.
Now, by the way, I do think that counts, and I do think there might be information here. 14% is not 0%. By the way, speaking as a former hedge fund quant, if I had 14% predictive power, I'd be making a lot of money.
Oh, yeah, sure.
But it's not.
How much do you need to make a lot of money? 4? 1%?
3.
3?
And it depends on
Depends on this time horizon.
It depends also on how much you pay for
Trades.
fees.
Yeah.
So, purported goal, find better teachers, punish bad teachers, get rid of bad teachers, blah, blah, blah. Political goal, this is all about politics. Yes?
Who makes the models? If it's a political-
Consultancies.
So they have a vested interest, or they're told the vested interest from...
Their vested interest is to get another job with the same public school system in the future. So their vested interest is to say, this is foolproof, it's going to be awesome. Their vested interest is not to a particular teacher or student or population. Their vested interest is to get more and more contracts. The interest of having this model, which is totally inaccurate, be used anyway is a way of like saying, oh, I could fire you right now, but I'm going to do you a favor and not fire. I'm going to do random numbers out, and I'm going to use these as excuses to fire you if I decide I want to fire you. Yeah.
You kind of contradicted yourself. You said if you had a 14% something or other in the stock market, you could make a lot of money.
Yeah.
And you said this thing is totally inaccurate, but it
Right.
did have 14% correlation. So it could be processed, as you said, to be useful.
That's right. I didn't finish that thought. Thank you for bringing me back there. It is absolutely not a complete lack of information. It is some information. So on the system-wide scale, it would be interesting to look at classes that happen after lunch versus classes that happen right before lunch, and you would get a trend maybe. You maybe find out that teachers do a little bit better on average after lunch than before lunch, but that's aggregating statistics at a very high level, right? What I'm saying is that at the individual level, it is not accurate enough to make an actual decision on hiring or firing. What I'm saying is that when you're dealing with people's lives, you have to be more accurate than that. So I think, and by the way, I happen to know how the tenure process works in New York City. You typically have 2 numbers by the time you are actually up for tenure. You just have 2 numbers. If you notice that you're being given 2 numbers that are 14% correlated to the true value of you, that's not enough. I mean, we do a lot better than that in academic mathematics, hopefully.
So 30.
There is no evaluation method. There is no evaluation method. This is how I know there is no attempt to make these accurate. They have never, at least publicized a study that goes and actually, one of the reasons they do this, one of the arguments is it's too expensive to evaluate teachers thoroughly on an ongoing basis. But it's not too expensive to do it for a couple of years at a couple of schools and check it against these numbers. They've never done that, or at least they've never said they've done that, because maybe they don't want to publicize how inaccurate these models are. There are ways for us to qualitatively judge teachers and say, this is a great teacher, and what is their value-added score? So by the way, going back to us as mathematicians, what is our responsibility? I do think that when we see a model which is being used as a weapon like this, that has no evaluation method, as mathematicians we can say, that's bullshit. This model needs an evaluation method for it to be considered a mathematical object. And it needs to have an ongoing process where we, the public, can see how well it's doing and making sure that it's being improved. The gaining potential is large. There's teachers that, as I said, take their kids out of school. There's administrations all over the country. This happened in Georgia too, where they just cheat on the tests. They change the scores in the students. This lifts that teacher's scores, obviously, because if you do it that dramatically, the model does pick that up. But then the next year, the teacher, if they don't cheat again, is hugely penalized. It's all over the country, and it's a growing thing. Okay, so my next example, I only have 20 minutes. Credit scores. I want to do 2 credit scores, 2 versions, just to compare. And so now I'm going straight into the world of the internet modeling. That's what I do as a data scientist. We have a credit score model. It's been around a long time. We don't really understand it, but we do know what the inputs are, because if you ask for your credit score, they don't tell you the number, they don't tell you the model, but they give you all the information that they use to compute your number, if anybody's ever gotten their free credit score. It's not really a credit score at all, it's just a list of information they're using. Their underlying assumptions is that if you are good at paying your bills, you'll continue to be good at paying your bills. The input is regulated. They're not allowed to use things like your race. They're not allowed to use things like who your daddy is. You get to see what they're using. The output is a single number. There's different models. There's like 3 basic models that you get, that people check when you make a loan or if you buy a cell phone or something like that. The purported goal is measurement of your credit worthiness. Political goals, probably still measurement of your credit worthiness. They want to quantify everyone in sight. This is a way of doing it. The evaluation method, I'm sure they have it, but I don't know what it is. It is an example of the death spiral, which I'm going to talk about in a second, my term. The gaming potential of this is not high. Why is it not high? Because it's a good model. I might complain about it. I might complain about its effects, the death spiral. I will talk about what that means. But it's actually a good model. What do I mean by that? I mean that if I tried to game this model, I would just pay my bills on time. I would, not lie. I would do everything that they want me to do. That's a good model, right? The proxies are, how do I pay my bills? That's pretty good. The reach is obviously national.
Yeah, but it's much simpler problem than the ones before.
Yes. Agreed. We can talk about the theory of modeling accuracy versus complexity, but that's a different talk. Let me talk about the death spiral modeling for a second. My best example is insurance. Let's say we don't have any sense of insurance for medical problems. But that means that every time we're all laborers. So anytime anyone gets sick, they spend all their savings, they go into debt because they got sick. Not a very good system. So we eventually come to the idea that we should pool our resources when we all put in $5 a week, so that when someone gets sick, they get paid out of there, and no one person goes, their lives aren't ruined. Okay, that's the idea of insurance. What happens when you add segmentation to that? Segmentation is a technical term from the internet where you say, hey, I know you. You came from a MacBook Air and you use Chrome. So you're going to be worth more for an advertiser. That's called segmentation. When you look at the attributes of a user online and decide that they deserve to be in a special bin. So what's the binning system in insurance? They're like, oh, well, you have DNA, or your father has asthma.
He died at 12.
What's that?
He died when he was 12 years old.
Or your father's deceased, blah, blah, blah. They look at the attributes of you and they're like, you know what, you're more at risk. You're more of a risk for us than other people, so your premium's going up. And by the way, you guys are healthy. You don't even come to the doctor. Your premiums are going down. By the way, every time this happens in any realm, everyone's like, great news. I'm not paying as much for medical insurance. But who's saying great news? The people that are healthy and have a voice. Who's getting screwed are the people that are poor and don't get to talk about how wonderful that is. This is not. Same thing with credit cards. Everyone says, oh, now we have credit cards where it pays you to be using it. But of course, that only goes to the people who can afford it. They nickel and dime other people. So the point is that if this continues to go on, as we get better and better and better at segmenting, which we are, okay? Medical research and data scientists are getting together. We're getting really good at pinpointing people. Let's just say we're unbelievably good at it. We can predict when everyone's going to get sick. Well, we're just going to charge them what they're going to cost. And that's not insurance. That's going back to having no insurance. Because everyone is eventually going to pay what they actually cost. But keep in mind that an insurance company's interest is in identifying exactly those people that are going to be expensive and not letting them into the plan. So that does happen. People who benefit don't see this problem. They see their premiums going down. They see their credit card not giving them money. But people who, so credit cards, but every time someone benefits, someone else is losing. You can be sure. This actually systematizes racism as well. In various ways, because everything is being used with his historical data. It's like people like you act like this, you get sick, blah, blah, blah. It doesn't matter why you got sick. And the death spiral bothers me, obviously. And it makes us sort of ask the philosophical question, what do we want to be as a culture? So I already talked about the credit score. That's a standard model that everyone knows about. There's something new that's being used more and more on the internet. The E-score, buying power. The underlying model is unknown. It's proprietary. It takes into account everything it can glean off of you from the web. The underlying assumptions, again, is behavior consistent over time. And there's, of course, an assumption that all the things they've tied you to are actually you. It's not like a mistaken identity problem. The input is unregulated. They can use anything they want, and they can use anything they find about you or the person they think is you online. They can use your race, your age, they can do everything you want, all the naked pictures you put on Twitter. Reporting goal is measurement. Of course, the actual goal is making money. The evaluation method, we don't know about it. The death spiral up here is very real. It's not regulated at all.
You didn't explain that phrase.
Yeah, I did.
You did?
Yeah, it was the previous slide. This is the death spiral, where you have insurance, and the people who are sick.
Okay, got it.
Yeah. So the point is that when you have, what's the death spiral for credit? Death spiral for credit is they peg you as somebody who doesn't pay back, or even better, their favorite victim is somebody who pays back only the minimum balance. So they make the minimum balance large. What does that happen? What's the death spiral? Well, I'm getting nickeled and dimed. I have a bad job. They know that. They're nickeling and diming me. I really needed this loan, so I took it, even though the terms were bad. I can't afford to pay it back. Now my next loan is even worse. It's sort of a spiral. It's making my credit harder and harder to come by and making my credit score worse and worse. It's also making other people's credit easier and easier to get to, and their terms better and better, and so they get into better and better situations.
I have a question. The first two models you pointed out were bad because they didn't predict well.
Yep.
These two models you're saying they do predict well, but they're forcing the prediction? Is that what you're saying? Or the good prediction shouldn't be used?
So this is a really good point. So there's various complaints I have with models. One of them is they're inaccurate and people pretend they're accurate. Those are the first two models. There's another one that's like they're actually pretty accurate, but they shouldn't be used.
Well, not the way they are used.
Not the way they're used. By the way, let's go back to the insurance thing. The model I was talking about was being able to predict someone getting sick, right? That's a wonderful model if doctors were using it, right? Wouldn't that be useful? Like, oh my God, you might get diabetes in the next 3 years.
It needs to be used.
You have to start checking your blood sugar. That would be a wonderful thing. Unfortunately, that's not who's developing it, and that's not how it's being used. Like, that's going to be used by insurance companies. Unless we make a policy that says you can't do that, or we change the insurance system. The gaining potential for East
Again,
Coast.
there's an inconsistency. The data the insurance companies are using to predict these things are kind of statistical again. The doctor is dealing with an individual, so you can't use that rough data to make sharp predictions.
But that's
about
exactly
that
what they
person.
do, though, for insurance companies.
No, they're using the statistics, though. These people are likely to get sick, so we're going to get rid of them.
Yeah.
The doctor can't say everyone who's likely to get this thing should take this strong medicine to avoid it, because, say, a third of them shouldn't be taking this medicine because it's not a good idea.
No, you have preventive care also. You can get special
It certainly depends. Like the information given to a doctor they would act on it differently than an insurance company. I agree with you.
Yeah.
Sometimes, though, the doctor would actually be able to make very good use of the fact that you have an elevated risk for diabetes, because you're just like you have to keep an eye on your blood sugar. That's not a medicine, right? That's cheap. That's useful. It's useful for you. They should know about that.
I see.
The gaining potential for these is not high. Again, it's like people do what they do. This is an international model. I think that this is going to be in 10 years. This is going to be the way like people get loans. So make sure you keep track of what you put online. Okay, I don't know why I messed up this, but it's supposed to be the H index. This is the map thing. I wanted to put this next to the other ones just to show you how it looks in the formal setting. The name is the H index. I'm sorry, this is wrong. The underlying model is just very simple. What is the maximum N where you have written N papers which each have N citations? The underlying assumptions in that papers and citations and quantity are meaningful about how good you are as a mathematician. That's an incredibly large assumption, obviously. The input is academic publishing records, published, not just archive, I assume. The output is a single number. The purported goal is to measure mathematicians for some reason. The political goal is, I guess, self-advancement of the person who invented this. I have no idea what they were thinking. The evaluation method, I suggest we say which ones have Fields medals. I mean, I don't know. Like, how do you evaluate that?
But it's bad because people use that across the different disciplines or sub-disciplines, but it begins to be much less meaningless if you begin to attach it to very precise sub-discipline of the field of science that you consider. I mean, of course, if you consider the same number for people doing computer science and people doing number theory or algebraic geometry or stuff like that, you will have problems. But if you look at a bit more carefully, it's not necessarily completely stupid.
If you look at it carefully enough, you're just looking at someone's resume. That's all I'm saying. I mean, I agree with you. By the way, I had this really interesting conversation with Jason in his office about how we would do this for real. And how would we, not even necessarily say whether a mathematician was successful, but whether a given paper was interesting. And it really depends on what you're looking for, right? If you're trying to learn a new field, you care about whether it's well written and whether it's central to the field and whether it gives you basic properties of the field. If you're an expert in the field, you're just, is it new? Have I read it before? Is it in my subfield? I mean, I really feel like data science, I'm not against data science, right? I think data science can be incredibly powerful, but we just have to really be careful and understand what we're saying, what our assumptions are. In particular, I feel like if we wanted to do a good job with this, we would have to allow a given person to come and say what they care about for that search. And then they could search the database by the ranking of their definition of what's interesting for them. So in a given situation, I might weight that it's original, that it's in algebraic number theory, and that it was cited by, I cited it. You know, like those might be the things I care about. I gave them each a weight of 1/3. But another person would come in with totally different weights. And that would be kind of an interesting, anyway, I'm getting off topic. But my point is, like, there are really useful and interesting ways to use data and to use modeling.
Yeah,
This is not one of them.
You could just modify that by looking at what is the H index of people looking, instead of using stupid numbers. Could count differently. I mean, I prefer to be cited by Dennis than to be cited by a random person.
I was actually talking to someone about the idea of using the Google ad rank. If you guys know what that is, it's a way of deciding whether a given web page is important by just like the links to other important. It's a recursive definition. But I think that would be an interesting way of thinking about papers.
Yeah.
Because there's okay, but in any case, the gaming potential for these things are really high. H-index is ridiculous because you could just, with a bunch of your friends, all publish end papers which cite each other in a journal that you made or something. I mean, it's stupid.
The physicist in Saudi Arabia says you could increase your citation index by doing errata.
Yes. I did that once, but that was a mistake.
Abraham, when he was accepted in the French Academy of Science, mentioned the problem of, at that time it was just number of citations. Saying it's the best we have, but it's completely stupid because my paper, which is the most cited, is a mistake in a paper early on. And since I'm now well known, every year there are a few people discovering that I made a mistake, so they write a paper just to mention it.
Nice. The reach is not very far, I hope.
Maybe we should make the young people leave the room.
There's lots of other models I didn't have time for. There's education models, like who's going to graduate, but it's really being used for people who can we loan money to that will pay us back. Debt collectors who will pay, even if we use illegal methods to try to extract money from them. There's political ads. Everyone's talked about how great it is that Obama won using data science. I'm sorry, that's not great. That is not great for democracy. That for me, that means like he just delivered whatever message he wanted to get you to vote for him. But nobody else heard that. Nobody else can like objectively like argue against it or for it. That's, for me, that's not democracy. That's like a secret little message. There's health and DNA models, which we
It's not, I will disagree, because the other guys spend even more on data mining, except that they did it in the completely stupid way. Well, what they did on the other side was really trying to understand correctly the model of the population that they had. So it was really the understanding of their people would lead them to a better targeting. So it's not completely right, but at least it has a level difference of what the other one spent even more. But they didn't understand what they are talking about.
I really do appreciate you guys helping me give this talk, by the way. We can talk about that, but I'm very worried about it. I've seen enough models be manipulative, which on their face are great news, but they're manipulative. And a lot, obviously, you know how much money is going to go into that by the time the next presidential election comes in. God knows what they're going to do. That's my point. Like when we have those glasses that give us little videos, we're going to have like political candidates telling us what we want to hear when we're walking to get our coffee in the morning. Modeling physics versus modeling people. Physics doesn't change because we've modeled it. People change because we model them. They change their behavior. So when the US News and World Report comes out with their 10 best universities, universities are like, how the fuck do I get on that list? And they change the way they report things. They change who they let in. They change how they pay their faculty and who their faculty is based on the way that model works. It's a feedback loop. Sometimes the feedback loop indicates that it's a bad model because it can be gamed. Feedback loops are often in the form of gaming, right? Like the H-index. But in general, in terms of modeling physics versus people, they're not statistics, right? People are not statistics. This is what I've said about how accurate do you need to be to actually not give someone tenure based on a score. You have to really know what you're talking about when you're doing that. You're supposed to, if it's an important life decision for them, it's important, it's not their decision, it's your decision. If you're making a decision based on a model, it should be very, very accurate before you start using it.
Right. In fact, people begins to be statistical when you look at the statistical behavior of people. It's the individual behavior that you should not treat as statistical.
Right. You can be statistical when you're making bets on the market. Because if you're right 52% of the time, you'll make money. It's just right 52% of the time. But you should not be doing that with people. You can't manage what you don't measure. I'm out of time, so I'm going to go quickly. So I want, just as a general philosophical thing, what are we not quantifying every time we make one of these models, and what should we be quantifying? So I want you guys to defend math. First, I'm coming here to tell you guys about this, but like I want you to think about this as an issue for mathematicians, if you will. I want you to, every time you see a model, here's what people are really bad at who don't do math. They can't anticipate the game. It's ridiculous. Like, you give me a model, I'll tell you how I'm going to game it 3 seconds later, if I understand what you're talking about. That's actually a skill that mathematicians have that the general public does not have. Another thing, a lot of this stuff, the dirty stuff, is hidden in evaluation methods which are not transparent or non-existent. I think we should always require transparent evaluation methods whenever a model is being used to make a decision on a person's life. And on the other hand, I don't want us to be economists, which is to say, I don't want us to like sell out and just sell our opinions to industry and be spokespersons for the industry. My suggestions directly are that I think there should be a review process or referee process for public models. Anytime there's a model which is mathematics and is reaching a lot of actual people, mathematicians should have a say. Why is that? Because it's being used as math. People are saying, oh, you wouldn't understand this as math. Mathematics is being used as a sort of a rubber stamp of authority. But it's never being, like the authority, which is you guys, is never actually being asked. Is it okay to use your rubber stamp?
It should be the AMS. AMS is not even able to defend the level at which people who do mathematics are paid. I mean, these people, there is
I actually
a
talked to
high level of incompetency at the top of the mathematical system, unfortunately.
So I've actually talked to somebody who talked to the AMS about this exact thing, and they already came out and said they doubt they're going to do this, but it's possible that they could write a statement of ethics for mathematical modeling, which is something. I would like the AMS to house a panel about mathematical modeling review. But if AMS is unwilling to do it, then we should just do it anyway. Obviously, models should be made as simple as they can be. Part of the value-added model that I didn't really describe is just how many steps there are. So it's actually impossible for anyone to understand how the actual test scores turn into a number. That's not good. Although we also want it to actually do what it's supposed to do. So you can't make it simpler than it has to be. There should be efforts to educate the public about what models do and do not do. Like how there's a difference between precision and accuracy. People feel like that's not their job, but you know what? People really don't understand that. And they have to be told that mathematicians aren't Superman and that mathematics isn't magic. Panels of mathematicians, but at the same time, I don't want to see us take money from the industry and directly profit from it, because then we're not going to be as trustworthy as people think we are. Thank you.
Are there more questions?
Too many.
You guys come with me next time I give this talk. I'm doing it once more in San Diego.
But what about your last day?
Yep.
A lot of expenses.
I mean, I think we should be paid for what we do.
But well paid. I mean, it's very high competency, very difficult to get, and very rare. And it's when you compare the salary of some of the best mathematicians to what coaches make in football teams in universities, it's too high. And there are even mathematicians who find it normal that the best mathematician be not as paid as basketball players or coaches. It's completely stupid.
Look, I mean, here's one thing I want to say. Like,
in 1 year, they do more than you do in 10 times your lifetime. Maybe not two, but most people do it.
when you look at, if you look into like medical pharmaceutical research stuff, you see some nasty stuff with professors taking money from pharmaceutical companies and just writing paper after paper about how great their drugs are. And they're lying.
Yeah,
I don't want to see that. That's all I'm saying. I don't want to see that.
You think because people have studied or are gifted in mathematics are less prone to be crooked like that? So 10% is enough.
I'll tell you what, I do think mathematicians are more likely to admit they're wrong. So.
Not if they're getting paid smart.
Right.
And these are not mathematicians.
Mathematicians are definitely corruptible.
These are people who have been trained as in mathematics.
You know what? I don't think that's a reason not to try to do this at all.
Rodney, did you have a question?
I was just asking about the model about citation. So, I mean, based on Google or something. So, did anyone try? Did anyone try?
I literally started thinking about it yesterday. That could be game though. Keep in mind, like, there's the people who. Let me just tell you a little story, if you don't mind. There's a current gaming, which is kind of my favorite gaming that I've heard about recently. Did you guys hear about Facebook? Like, people are pissed because they're paying for all these clicks on Facebook, but 20% of them are fake. Like, where are those fake clicks coming from? Like, what does that even mean? Fake clicks. So when you're advertising on Facebook, you only pay when someone clicks on your ad. You don't pay for the actual ad showing up.
Okay.
You only pay for the clicks. But somehow they figured out that a bunch of the clicks they were paying for were fake. They were not real people, they were robots. And I sort of like, well, that sounds like somebody's gaming something, but what is going on? And I talked to somebody who works inside that world. And he explained that there's like 1,000 or 1,200 websites that have been set up that are all fake, that none of them are ever visited by any humans. There's some of them, and you can tell they're fake because they all have reasonable sounding names, but they're all random Like one of them is for shoes, one of them is like Chinese puppies, you know, like completely, and they have a lot of interconnectedness. And what they do is they add cookies to people's cookies. They just sort of like slap on a bunch of cookies that make it look like that person traveled through all 1,200 of these sites. Okay? So that sounds kind of random. Why would someone do that? Well, the reason they do that is because advertisers are stupid in the way they choose to pay, how much to pay for a given user. So they look at a given user's cookie and they say, oh, that person has been to a lot of sites and they've been to a lot of interconnected sites. So they have a concept of interconnectedness. And they've set up this web of fake sites to look interconnected. So that specifically so that this proxy of a good-looking user will be satisfiable. So in the end, what they're doing is they're paying a lot of money for advertisement, and then those sites are actually collecting that money. So it's an incredibly large backing up like system that they created just to collect money off of, they're gaming a system, the advertiser's choice on how much to pay for ads.
There are protections against that.
What's that?
There are protections against that.
Yes, but when you talk about math, and you talk about like math papers and citations from other things that are cited a lot, you can set up journals that have, you could have set up journals that have lots of citations with each other, and papers that have citations with each other that are all fake. So you can game that system. Actually, everything can be gamed. Every one of them that we talked about. However, one of the things I like about the idea of having you come in and defining your own definition of what I'm looking for, what's interesting to me, is that they can't game everybody's definition at the same time. So they'd have to choose a few things to game. But it's definitely hard. It's a war. It's a war. It's the people who model for the good guys versus the people who are predators on those models. And you have to constantly be aware of how your models are being gamed and make up for those things. It's like a science fiction novel, except it's real.
Well, with that, let's think Cathy, you can